Hello there. In this video, we will be evaluating radical expressions based on another given radical expression. What's given here? X plus square root of x is equal to 5. What you see here, it is the upper part is the first one given to us, and then we are going to calculate or evaluate x plus 5 over square root of x. We can do this in two methods. The first method is a simpler one, that is method 1. You can see what to do here. In place of 5, we can substitute x plus square root of x. This is the same as 5. Don't forget they are equal. Therefore, the second expression will be, this is the second one. The second expression will be x plus square root of x the whole over root x. We'll have this. This is what we are looking for. So in place of 5, x plus radical x is inserted. Then we can rationalize this one, root x over root x. We can do as you like, or by crisscross you can complete it, but rationalize is preferable. So what we'll have, x plus, when you multiply root x in the upper part, x root x plus just x the whole over x will have. Then we can extract the x as common here. Then what we will have, x plus just x common out, root x plus 1 remain in the bracket, the whole over x we have. Then you can cancel x with x here, and then x plus root x plus 1 remain. But don't forget again, x plus root x is the same as 5 already from the first equation. So 5 plus 1 will be 6. That is the final answer in the simpler method. This is it. When you go to the second method, the second method is directly we are going to solve the first equation and get the value of x. It is radical expression. We can do the first equation in different method. One of the method is try to make the square root of x alone. Root x is equal to 5 minus x. It will be by reshuffling, and then square both sides and remove the radical, and it's going to be some kind of quadratic. You can continue that way. The other way, don't forget the domain must be x greater than 0, because first of all, square root of x there means the domain must be greater or equal to 0, but what is asked to evaluate is denominator root x, so cannot be 0. We have to restrict the domain that. The other way of solving, let us say radical x is equal to any variable, you can say it m. Then if you square both sides, x will be m square. Let us substitute this in the first equation. So in place of x, let us insert m square plus just m, then bring the 5 to the left side, is equal to 0. It's a quadratic. We can solve this quadratic by formula, because we cannot factorize. We cannot easily factorize. Finding two number product, -5 and some 1, will be somehow time taking. So let us apply formula. M is equal to negative b means -1 plus or minus the square root of b square is just 1 minus 4ac means 4 times -5 plus, which will be plus 20, the whole over 2. Then m is equal to -1 plus or minus square root of 21 over 2. But -1 cannot be taken, because we have here two answers, one negative, one positive. -1 minus radical 21 will not be taken, because m cannot be negative, as you see here. Therefore, the m value necessarily has to be -1 plus square root of 21 over 2. We have this. This is m. Don't forget, m is the same as root x, radical x. But what about x? X is the same as m square. So we need to square this result and then get the x value, because we are looking for x plus 5 over root x. We got the root x already. Here it is. This means root x, because m is radical x already. So we have to get it, the x. The x is m square. Let us square and get it, and then we are going to insert it. Okay. So what do we say? M is equal to radical 21 minus 1 the whole over 2. This is M, which is root x, the same as root x. Now let's find x. X means m square. That means we are going to square radical 21 minus 1 the whole over 2. Square it. When you square, the upper part is radical 21 minus 1. When you square it, it's a form of a square, like a minus b the whole square, which is square minus 2ab plus b square form. So we can write it like a square means radical 21, which is 21, and negative 1 square is 1. It will be 22 minus 2 radical 21 at the middle, the whole over 4 will have. Then by extracting 2 as a common, because 22 is 2 times 11, and here also minus 2 times radical 21, the 2 will be cancelled. Okay, the 2 will be taken out as a common and cancel, and this will be 2. So what we will have, x is equal to 11 minus radical 21 the whole over 2. This is x. We have x and we have root x. Now let us insert everything what we have. Let's evaluate, because our evaluation will be x plus 5 over square root of x. This is what we are looking for, and we have x, here it is, and we have root x also, the above one. Somehow time taking this method. The first one is a basic method, but we have to know also how to solve in equation way, because mostly the students are reacting that method, this method, so we don't have to be confused. Therefore we need x plus 5 over radical x, which is the x is 11 minus radical 21 over 2, we said, plus 5 over what is root x, radical 21 minus 1 over 2. When you flip it, it's going to be, this one will be flipped and it will come up, so it will be 11 minus radical 21 over 2 as it is, plus the 2 will come up and it's going to be 10 over square root of 21 minus 1. Then we can do it by crisscross or by rationalization, as you like it, but it's better here to rationalize this. Rationalize the second one, radical 21 plus 1 over radical 21 plus 1. So it's going to be, let us complete it, 10 in bracket radical 21 plus 1 the whole over, the down part will be 21 minus 1, which is 20. 21 minus 1 will be 20, so I can write 20 here and I can cut the 0 here. Then what I will have, 11 minus radical 21 over 2 plus radical 21 plus 1 the whole over 2. Now as you see here, the 2 addend, they have the same denominator, therefore I can add the numerator directly. So that means radical 21 will be cancel each other because they are opposite in sign. So 11 plus 1 will be 12. 12 over 2 is the same as 6. So finally the answer will be 6, like we did before. By the first method we got already 6. The second method also it is 6. So this is the way how we can evaluate the given radical expression. Thank you for watching. Don't forget to like, comment and share.